Hello students, welcome to my channel. In this class, I am going to teach you transportation problem, solution of a problem using lowest cost entry method or method of a matrix minima, in which we have to find the feasible solution of a transportation problem. So the process by which this method will be applicable, I am going to explain it step by step. First step, find the lowest cost cell, that is Cij. Suppose I stands for row, J stands for column, and allocate the cell Cij minimum amount available AI Bj. That means available in that row and that column. Suppose the quantity is the cost quantity is Cij. If that Cij equals to Ai, then we have to cross the first row and we have to decrease the row Bj by we have to decrease the column quantity Bj by Ai. Then we have to move the next step. If Cij is equal to Bj, then cross up the jth column, decrease Ai by Bj, and we have to move to the next step. In third step, we have to repeat step 1 and 2, and the process will continue till all the available quantity G exhausted. Sometimes we find the lowest cost cell is not unique. In that case, we have to select the cell where we can allocate more amount. This is the process by which we can apply method of matrix minima to find the feasible solution of a transportation problem. Let us solve a problem by which the process will be more clear to you. Okay, now the question is, using matrix minima method, find an initial basic feasible solution to the following transportation problem. Destination D1, D2, D3, D4, and here origin, demand is 4686, capacity 6810. So we have to solve this problem. So let us solve this problem. Now solution. Given the table, so this is the table given to us. So if we observe, the lowest cost is in cell 24 and cell 31. So we can allocate maximum amount to here, that is 6 in cell 24. Whereas in cell 31 we can allocate maximum 4 unit. So that is why we have to choose cell 24. We have lowest cost in cell 24 and cell 31. We have to choose cell 24 because we can allocate maximum amount here, that is 6. we have to choose cell 2, 4 and allocate 6 units. So we can allocate 6 units here. So let us allocate 6 here. So we are left with 2 units only and it becomes 0 now. So our first allocation is completed and the allocation is made in cell 2, 4. Okay. Now let us proceed to allocate in cell 3, 1 because the next lowest cell is C3, 1. Next, let us allocate 4 units. 4 units to cell 3, 1. So this is cell 3, 1. We can allocate here 4 units. So this is exhausted and here we are left with 6 units only. So next we are having the minimum cost here 2, here also 2, here 2. Here we can allocate the quantity 6. Here we can allocate 2 and here we can allocate 6. So let us choose cell 1, 2. Now we have to move cell 1, 2 where we can allocate 6 units. So here we can allocate 6 units. So we can allocate here 6 units. So that this is exhausted and this one is also exhausted. So after that we have to proceed to this 2 where we can allocate only 2 units here and here we can allocate 6 units. So let us proceed to say then we move to cell 3, 3. Move to cell 3, 3. We move to cell 3, 3 where we can allocate 6 units. 6 units. So here we can allocate 6 units. So this exhausted becomes 0 and we are left with 2. Now the cell 2, 3 is left where we have to allocate. Then we can allocate in cell 2, 3. 2, 1, 2, 2, 2, 3 in which we can allocate 2 units. Then we can allocate in cell 2, 2 that is 2 units. So our allocation is now complete. Now the feasible solution to the transportation problem. Then the required feasible solution to the transportation problem is equals to 6 into 2 plus 2 into 2, 6 into 2, 2 into 2, plus 6 into 0, plus 4 into 0, plus 6 into 2. 6 into 2, 2 into 2, 6 into 0, 4 into 0, 6 into 2. So this is equals to 12 plus 4 plus 12 is equal to 28. Hence, the required feasible solution is rupees 28. Answer. So we have solved the problem by method of matrix minima or lowest cost entry method. So the problem is now solved. The topic for today's class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.